In this lesson we're going to look at isomerism in the alkanes. Now, first of all, let's state what we mean by isomerism, and we can say this, that an isomer is a compound with the same formula but with a different structure. Okay, so if we look at the first three members in the alkane family, that's to say methane, ethane and propane, they have the formulas CH4, C2H6 and C3H8. And these are what we mean by their structures. So these are the structural formulas and these are the chemical formulas. Now in these three cases there is no way that the structural formulas can be different. There's no way that we can really change the structural arrangement of these molecules. So in the case of the first three alkanes, we can say that there is no isomerism present. But in the case of the next alkane, which is butane, something different happens. First of all, as we see here, we have the standard butane molecule, which is the 4 carbon atoms in a linear chain. This is known as N-butane, which has the molecular formula C4H10. But what can also happen is this carbon atom here can join on and form a bond with this carbon atom to form this structure. And this is the other isomer of butane. So we say butane has two isomers. They both have the same chemical formulas, right? This is C4H10, this is also C4H10, but they clearly have different structures. And in the area of naming isomers, this CH3 group here is known as the methyl group. And so the name of this isomer of butane is going to be called methyl, because of the methyl group, and then propane, because there are 3 atoms in the chain here. Right, so that's known as methyl propane, which can be a bit confusing because it's actually an isomer of butane. Alright, so we're going to stop there because we're only at GCSE or IGCSE level, and obviously what will happen next is as these chains get longer and longer, the number of isomers and possible structures that become available become more and more and more, and the naming can be more and more complicated, but we're not going to go into that now. But one thing I would like to say is this, that because of the different structural arrangements of these molecules, their properties are different too. That's to say their physical properties and their chemical properties. Now, I'm not going to go into the chemical properties at the moment, but we need to recognize that there are immediate differences in their physical properties, particularly boiling point, melting point. And that's a typical sort of question that you might be asked in an IGCSE exam, is explain the difference in boiling points between these two structures of butane or some other isomers. Okay, so the boiling point of N-butane is minus 0.5 degrees Celsius, while the boiling point of methyl propane, also known as isobutane, I ought to make a note of that, is minus 11.7 degrees Celsius. So this has the higher boiling point, and the reason for that is that the molecule is in a long chain. That means that the surface area of the molecule is greater. That means there's more interaction with other molecules, so the van der Waals forces will be greater. So when we come to the methyl propane molecule, the overall surface area of the structure is smaller, therefore there will be less interaction between the molecules, and the resulting van der Waals forces between them will be less, they will be weaker, which means that its boiling point will be lower. That's to say, this molecule finds it easier to get into the gas state, for example, than this one, because the van der Waals forces that hold it together are weaker.